Now, in last lecture, we have seen how to find pi when capital X is equal to e raised to ax. So, formula for pi was 1 upon fd e raised to ax is equal to 1 upon fa e raised to ax, where fa is not equal to 0. That means when capital X is equal to e raised to ax, then to find pi only we have to substitute d by a, and if f of a is not equal to 0, then our pi is 1 upon f of a e raised to ax. But now we have to see that if f of a is equal to 0, then this will happen if there is a factor d minus a in fd. That means fd is equal to d minus a into remaining function phi d. If we put here d is equal to a, then this is a minus a, that is 0, and this fd f of a becomes 0. When we put d equal to a, f of a is equal to a minus a phi of a, but a minus a is equal to 0, therefore this becomes 0. So we have to find pi when there is such factor d minus a. So we find here pi. So pi is equal to 1 upon fd into capital X. Here capital X is e raised to ax. Therefore this is equal to, this fd is equal to now d minus a into phi of d. Here this phi of d is a function where if we put d equal to a, it is not equal to 0. Phi a is not equal to 0. So 1 upon d minus a into phi d e raised to ax. Now to find value of this, here are product of two factors, one d minus a and another is phi of d. So first we keep 1 upon d minus a as it is, and we operate 1 upon phi d on e raised to ax. Therefore this is equal to 1 upon d minus a into 1 upon phi d e raised to ax, means here we can use our result, that is for e raised to ax 1 upon fd e raised to ax is equal to 1 upon fa e raised to ax. Here instead of fd we have phi d. So if this phi a is not equal to 0, we can use this result. So using this result, 1 upon phi d e raised to ax is equal to 1 upon phi a e raised to ax. So now this phi a is a constant number. We can write outside 1 upon phi a into Now we have to operate 1 upon d minus a on e raised to ax. Now this can be solved. We know the formula for this general formula. We know that 1 upon d minus a into capital X is equal to e raised to ax, this a, e raised to ax into integral e raised to minus ax into capital X. Here capital X is e raised to ax. So using this formula we get this is 1 upon phi a, and this is e raised to ax, and into integral e raised to minus ax into e raised to plus ax, it becomes e raised to 0, that means 1 dx. Therefore this is only integral dx is equal to x. So we get 1 upon phi a e raised to ax into x. So this is pi if there is a factor d minus a in fd. Then for that factor we write here x, and remaining 1 upon phi d e raised to ax, we can use the result 1 upon fd e raised to ax is equal to 1 upon fa e raised to ax. So in phi d we can put d is equal to a and write 1 upon phi d e raised to ax. So only for the factor d minus a we have to write here x. Otherwise in the remaining function phi d you can put d is equal to a and write pi as 1 upon phi a e raised to ax into x. So this is the result for one factor d minus a. We can write x here, and for phi d we can put d equal to a. So this is pi. Now if this d minus a factor is repeated twice, that means if there is a factor like d minus a bracket square in our fd, then that means fd is equal to d minus a bracket square into phi d, and here if we put d equal to a, this fa is equal to 0. Due to this factor fa is equal to 0, so we cannot put d is equal to a here. So now we find what is pi for this d minus a bracket square. So pi is equal to 1 upon d minus a bracket square into remaining function phi d, where phi a is not equal to 0, into e raised to ax. Now here we first operate 1 upon phi d on e raised to ax, and here we use the result 1 upon fd e raised to ax is equal to 1 upon fa e raised to ax. Therefore this 1 upon phi d e raised to ax becomes 1 upon phi a e raised to ax. So this is equal to, now 1 upon phi a is a constant number, we can write outside 1 upon phi a into, now we operate 1 upon d minus a bracket square into e raised to ax. So 1 upon phi a into this 1 upon d minus a bracket square we can operate 1 by 1. So 1 upon d minus a into 1 upon d minus a e raised to ax. So this is equal to 1 upon phi a into 1 upon d minus a, and we operate here 1 upon d minus a on e raised to ax. This is done. We above, and the value of this is x e raised to ax. Here this is 1 upon d minus a e raised to ax. After solving, we got x e raised to ax. So here we put x e raised to ax, and now again we have to operate 1 upon d minus a on x e raised to ax. So again using that formula, therefore e raised to ax into e raised to minus ax into capital X means this x e raised to ax dx. So this is equal to integration sign, this is only remains x dx. So this is equal to 1 upon phi a e raised to ax, and integral of x is x square upon factorial 2. So if we increase the factors d minus a, then we have to integrate this last term. So if there is a factor 3 times d minus a bracket cube, then that pi will be, only we have to again integrate this x square upon 2, we get x cube upon factorial 3. So in general we can write formula for if d minus a is a factor r times repeated, then pi is equal to 1 upon d minus a bracket raised to r into phi d e raised to ax. This is equal to, for this factor we can write x raised to r upon factorial r, and for 1 upon phi d e raised to ax we can write 1 upon phi a e raised to ax. So remember this formula, if there are r factors d minus a, r times d minus a is a factor, then pi will be x raised to r upon factorial r into, put d is equal to a in a remaining factor where this phi a is not equal to 0, and e raised to ax. So this is our formula if f a becomes 0, and if due to d minus a is a factor in f d. So formula for that is this. So remember this, and we have to use this formula to solve the examples. So we stop here.